Good morning, students. Today we shall study the properties of two commercially important compounds, important carbon compounds, ethanol and ethanoic acid. First, ethanol. So ethanol is the second member of the homologous series of alcohols. So this is the chart here, the methanol, ethanol. I'm just showing here so you can see this. So the methanol is also known as the methyl alcohol. And let's see the preparation of ethanol. And on a large scale, it is prepared by the fermentation of sugar or starch with enzymes present in yeast. And let's see some physical properties of the ethanol. The ethanol is a liquid at room temperature. Ethanol is commonly called the ethyl alcohol or simply alcohol. And the consumption of small quantities of dilute ethanol causes drunkenness. And when large quantities of ethanol are consumed, it tends to slow metabolic processes and to depress the central nervous system. This results in the lack of coordination, mental confusion, drowsiness, and lowering of the normal inhibition, and finally stupor. And here we know that the person loses sense of discrimination under the influence of ethanol. With the increase in the dose of alcohol used for drinking, the body loses its control. Gradually, one loses one's consciousness. No, and the ethanol. Okay, ethanol. Yeah, and this one, the third physical property of the ethanol is soluble in water in all proportions. You have to remember this one. Now let's see the chemical properties of ethanol. The reaction with sodium. The ethanol reacts with sodium. This ethanol reacts with the sodium in the cold. Okay, in the cold to form sodium ethoxide with the evolution of the hydrogen gas. So the reaction is this: twice Na react with the ethanol, produces sodium ethoxide and hydrogen gas. And the ethanol, again, when we heat the ethanol with the excess of concentrated sulfuric acid H2SO4, then you will get unsaturated hydrocarbon ethene. Okay, so ethene is produced when ethanol is heated with the excess of concentrated sulfuric acid. And now let's see the uses of ethanol. Ethanol is used in alcoholic beverages, and it is used in the preparation of dyes and cosmetics. Then ethanol is used as a fuel. And then ethanol is used as a fuel in internal combustion engines in the form of the power alcohol. Okay. Now let's see again another uses of the ethanol. So ethanol, okay, especially in the cold countries, used as an antifreeze in the radiators of the automobiles. Okay, this is the uses. These are the uses of the ethanol. Now let's see the next. Okay, the next another important carbon compound, that is the ethanoic acid. So ethanoic acid, the second member of the homologous series of carboxylic acids. And first member is the formic acid, that is the methanoic acid. Then ethanoic acid, propanoic acid, butanoic acid is here in this chart, you see there. And then remember the preparation. Okay, let's see the preparation of the ethanoic acid. When ethanol is treated with the acidified solution of potassium dichromate, first ethanol is formed, which is further oxidized to form ethanoic acid. And then, a 5 to 8% solution of acetic acid in water, and this acetic acid acetic acid, and acetic acid is the common name of the ethanoic acid. Okay, so a 5 to 8% solution of acetic acid in water is called vinegar, and this vinegar we know that is used as a preservative for making the pickles. Okay, now the physical properties of ethanoic acid. The melting point of pure ethanoic acid is 290 K. And then these carboxylic acids, you have to know that carboxylic acids are weak acid. And then this ethanoic acid is miscible in water in all proportions. And then this methanoic acid, okay, ethanoic acid is colorless liquid, having a very strong pungent smell. So these are the physical properties of the ethanoic acid. And then now let's see the chemical properties of the ethanoic acid. Ethanoic acid is very important one. Let's see the chemical properties of the ethanoic acid. Number one, carboxylic acid. Okay, this carboxylic acid, so here the ethanoic acid here, okay, this carboxylic acid react with alcohol to form esters, okay, and esters are widely distributed in nature. The fragrance of fruits and flowers largely due to esters. The fragrance of the fruits and the flowers, they are having, it is due to or presence of the esters. You have to know that. And then ethanoic acid reacts with the alcohol in the presence of the sulfuric acid to give the ester which possess pleasant fruity odor. So reaction, let's see now here, CH3COOH, this is ethanoic acid, is a carboxylic acid. When reacts with the what? C2H5OH, ethanol. So ethanol is an alcohol, okay, in the presence of what? In the presence of concentrated sulfuric acid H2SO4, and if we heat, then we will get the ethyl ethanoate. So ethyl ethanoate is an ester, and then together with this ester also will give the water. So you don't know this reaction. Now the next one reaction, okay, the next reaction, before we go to the next reaction, you have to know these certain facts. The reaction, okay, the reaction between carboxylic acid and alcohol, okay, to form an ester, okay, ester is called the esterification reaction. Esters on heating with an aqueous acid or a base give back the original alcohol and the original carboxylic acid. This reaction is called hydrolysis. When hydrolysis of an ester is carried out with a base such as sodium hydroxide, sodium salt of the original acid and the original alcohol are formed. We know sodium salts of higher fatty acids are called soaps. So alkaline hydrolysis of an ester to give the salt of the corresponding carboxylic acid and the alcohol is called sulfonification. Okay, so this sulfonification is reverse of esterification. Remember this thing. Okay, the next is ethanoic acid. Now let's see now here, ethanoic acid reacts with a base here. Now, ethanoic acid reacts with a base such as sodium hydroxide. Okay, here this reaction, you see there, sodium hydroxide to give a salt and water. So reaction is here, sodium hydroxide when react with the ethanoic acid, they produce the sodium ethanoate, and this sodium ethanoate is a salt and also giving the water. So remember this one, H2O. And then again, when ethanoic acid reacts with carbonates and the hydrogen carbonates, okay, a salt, then carbon dioxide are formed. So reaction, The first one here, ethanoic acid, okay, twice CH3COH reacting with the Na2CO3, this is the sodium carbonate, then produces sodium ethanoate or sodium acetate, okay. This twice CH3COONA, this name is sodium ethanoate, okay, sodium ethanoate or sodium acetate we can say, okay, either this sodium ethanoate or sodium acetate. And then also forms the water and the carbon dioxide, no. And then another one is the ethanoic acid, okay, ethanoic acid CH3COH when reacting with the sodium hydrogen carbonate, okay, NaHCO3 produces CH3CONA, that is the sodium acetate or sodium ethanoate, okay, with the water H2O and the carbon dioxide, okay. This is the reaction, okay, different reaction, chemical properties of the ethanoic acid. Now again we'll see the uses of the ethanoic acid. And this ethanoic acid, okay, ethanoic acid is used in the manufacture of dyes, perfumes, pharmaceuticals, and plastics. Remember, okay. So these are the uses of the ethanoic acid. Now, okay, you write the questions, these following questions, and after writing the question, then you find out the answer. Okay. So first question is, what is denatured alcohol? And next one is, what are esters? How are they formed? Then the third one is, how can ethanol and ethanoic acid be differentiated on the basis of their physical and chemical properties?